Hello and welcome to another video, this time going through Math 2010 question 6. I'm going to try and do question 6s and even 7s actually, and I know question 7 isn't in the test this year, but question 6 and 7 look pretty similar to me really. They're kind of like maths in an applied context. A lot of the times they're kind of logic problems as well, which I really enjoy actually, and they can be quite nice, but I can totally understand why you might want me to go through this in terms of like how you notate your answer and how you show the examiner your reasoning, because I think it's very difficult to do. And please do comment if you think that I haven't been precise enough in the way I've responded, because I will certainly listen to your comments and perhaps even agree with you, because it's pretty hard sometimes to get across your reasoning on these questions. So let's discuss it and decide what we think is, clear enough to the examiner so that our answers are accepted. Okay, before I continue though, can I just point out my YouTube channel is moving to this channel here. You see a picture here of Peterson's graph still, which is what was on my other channel. That's Peterson's graph there. This is just a rearranged version of Peterson's graph. That will show you on the new channel. I haven't got all my videos up there yet. I can only upload about 20 or 25 per day, but they'll eventually, or 15 by the look of it actually, they'll eventually all be up there. Basically YouTube's trying to stop me spamming them, so I'm gradually adding them. But in about a couple of weeks I'm only going to be adding my math videos to this channel and my step videos as well. I basically want to have this channel for extension papers only. I might put some A-level stuff on there as well actually, but I want it tidier. My old channel, I have I'm answering questions from students in my classes, which is fine. I'm going to keep it running and stuff, but I'm not going to be adding my extension paper solutions to this channel anymore. I'm going to be putting it strictly on this one. So do join this channel and subscribe to it if you want to continue watching my math and step videos. Okay, so here's it, Oxford Math 2010 question 6. Now, okay, so I quite like these ones, but I'm always, probably quite similar to you, worrying about whether they'll accept my answer, because I understand the answer, but can I explain it? That's the challenge. Okay, we've got saints, and saints always tell the truth. Yeah, so they're like omnipotent beings, if you like, who always know the truth and hence only ever utter the truth. Liars, also like, demons, if you like, they always know the truth, but they utter a lie, if you see what I mean, yeah? So think of these, these aren't beings who are fallible or anything like that. They know what the truth is and either always tell the truth or always lie about the truth. Okay, and we've got them sitting round a table, yeah? And basically we're told that all 6 of them say the person directly opposite me is telling the truth, yeah? One possibility is that all 6 are lying. And that's certainly true, isn't it? Because these questions are always about consistency, yeah? What is logically consistent? Now, when you think about it, if everybody, just think about a pair of people, yeah? Because we're talking about the person directly opposite us. So let's think about P1 and P4. Okay, if both P1 and P4 say the other person's a truth teller, well, one possibility is that they're both telling the truth. Yeah? And that's consistent. They both tell the truth. Because if they're both describing each other as truth tellers, then it's perfectly possible that they're both truth tellers, yeah? On the other hand, I'm going to write they both tell the truth. They both tell the truth tellers. Oops, as I'm talking, I sometimes write incorrect things, so I need to be careful with that. So they both tell the truth is consistent, yeah, and they both lie is consistent as well. Now, why is this consistent? Well, they've told us it's consistent. And when you just think about it for a second, you think, yeah, if this one describes the other person as a truth teller, but they are a liar, then the other person must be a liar, which is consistent with what they say about P1 being a truth teller. Yeah? Do you see what I mean? Because they're both lying, they're both born liars, if you like, it's perfectly okay for them to describe each other as truth tellers. Like, it is logically consistent. Okay, so we've got 2 possibilities for each opposing pair, haven't we? Now we've just got to think about how many ways there are of doing that, yeah? So we've explained firstly that they must both be telling the truth or they both lie. Now, in terms of the number of arrangements, let's spell arrangement correctly and not look completely daft. Okay, is going to be equal to, well, there's 2 possibilities for P1 and P4. And then there's 2 possibilities for P2 and P5. And there's 2 possibilities for P3 and P6. Yeah, this is the way you count possibilities. Basically, this is going to be a power of n problem, isn't it? Like if there's 3 pairs and it's 2 to the power of 3. Think about it in binary. It's exactly the same as binary of how many ways there are of writing 0, 0, 0 right the way up to 1, 1, 1. Yeah, how many different numbers could that represent? Well, 8, because you're going to have basically a choice of 2 for each possible position. Yeah, 2, because this could be 0, 1 times this could be 0, 1, or times this could be 0, 1, so 2 times 2 times 2. So there are 8 possibilities. Yeah. Now, I'd quite like to compare my answers to the answers. I haven't actually looked at the answers in the map carefully or anything like that, but it would be nice to compare mine at the end to theirs and compare the marks, because you never know where the marks are, so you wonder about how much detail to put in. Yeah, you could even list all possibilities here, couldn't you? Because for P1 and P4, you've got T or F. It's basically like a truth table. If you've ever done truth tables before in like philosophy or logic, like you've got you could have TT. Basically TT, TT, F, 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 F. Like, this is one way of drawing out all possibilities. For the next one, you could have TF, 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 TF. F is maybe I should use saints and liars, actually, as they're talking about saints and liars. I'll just quickly draw this out. This is like a truth table with 8 possibilities. I remember doing it at uni. But, yeah, you could have saint, 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 liar, 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 liar. You could have saint, liar, saint, liar, saint, liar, saint, liar. Or you could have, now what other way could we do this? We could do this as saint, saint, liar, liar, saint, saint, liar, liar. Okay, I think I've got all 8 possibilities there. Should we check? I've tried to do it systematically, basically, and this is working nice because I've got all the ones with saint first here because I've got SS, LS, SL, and LL. Then I've got all the ones with liar because I've got SS, liar first, SS, LS, SL, LL. Yeah, there's 8 possibilities. Hopefully they would accept that. We'll have a look at how many marks this was worth at the end. It'll be interesting. We can see, I probably wouldn't have got full marks there. Okay, suppose now that all 6 people say the person to my left is lying. In how many different ways can this happen? And the dreaded phrase, explain your reasoning. Wow, that's some weird spelling of reasoning here. Wow. So yeah, there we go. A typo. It's always fun to spot a typo. Okay, in how many different ways can this happen? Well, okay, this never hurts. This trick for logic problems never hurts. Actually assuming, writing the word assume. So it's like proof and proof by contradiction. It very much is exactly this. I'm going to assume P1 is telling the truth. Yeah, because then I could always repeat the process assuming P1 is lying, yeah, and then figuring out and how many possible ways this can happen. Yeah, if P1 is telling the truth that the person to the left is lying, now let's have a look at who's to the left of P1. Well, it depends whether you go up or down, really. Let's sort of take left as clockwise, shall we? Because I think that's slightly ambiguous, yeah. Assume P1 is telling the truth, then P6, assuming P6 is to the left, if P1 is telling the truth, then P6 is a liar, yeah? So we'll say P6 equals L, yeah? And then, yeah, and you can use these little conditional arrows here, P5, now P6 is lying, yeah? And he's lying about the person to the left of him lying, so the person to the left of him must be telling the truth, so P5 is a saint, yeah? And you can follow this reasoning along, and you can see that P4 is going to be a liar, P3 is going to be a saint, P2 is going to be a liar, and P1 is going to be a saint, yeah? Now the key thing is P1 is telling the truth, and so he should be a saint, because we assume P1 is telling the truth, and so this is consistent, yeah? Yeah. On the other hand, which you might abbreviate to OTOH, on the other hand, I've seen step solutions, they abbreviate on the other hand to OTOH. Assume P1 is lying, yeah? Okay, if P1 is lying, then P6 is a truth teller, P5, it basically goes the other way round, is lying, then P4 is a saint, then P3 is a liar, then P2 is a saint, and naturally we get consistency. You probably worked this out in your head. P1 is a lie, and so this is consistent, and hence there's just two ways, because each one of those, like if-then statements, that's the only possibility, isn't it? Like if P1 is telling the truth, then P6 must definitely be the liar, then P5 must definitely be the saint, then P4 must definitely be the liar. So there's only two possible ways, hence only two possible ways. Yeah, basically SL, 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 or LS, LS, LS. I can't do LS, LS. Yeah, you get the general idea. Apologies for my handwriting. Okay, part 2. Okay, now N people, Q1 to Qn, sit in order around a circular table with Q1 sitting to Qn's right. So I drew a little picture. It wasn't a great picture or anything, but I immediately drew something like this, and I just wanted to show that Q1, Qn, yeah, and dot, 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 yeah. So I think I've fulfilled that condition that Q1 is sitting to Qn's right, yeah, and I'm looking at the bottom, but you might have drawn it the other way around. Obviously it doesn't matter, it just means you're looking from the other side underneath the table, if you like. Okay, suppose that all M people make the statement, the person on my left is lying, and. Now these questions are always about the difference between and or. Yeah, they're not the same. Suss out what is the logical difference between an and statement and an or statement. It's precisely exactly the same distinction between intersection and union in set theory. It really is, and you want to understand that. You really do. That's what most of these questions are getting at, and it's how they make it difficult. So, okay, right. Suppose that all M people make the statement, the person on my left is lying and the person on my right is telling the truth. Yeah, so person left lying and I'm going to write it like that, person right telling the truth. I'm just going to put saint. Yeah, so both these conditions must hold for that statement to be true. Yeah, and if either condition doesn't hold, that is false. So if, for example, someone said the person on their left was lying and the person on their right was a saint, and one of those holds, so the person on the right is a saint, but the person on the left is a saint as well, then that person has lied. Yeah, to break an and statement, you just need one side of the and to be false, yeah, in order for the whole statement to be false, whereas or is not like that. To have an or statement hold, then either or, either one thing or the other thing must be true. Yeah, and then it's true. So, okay, explain why everyone is lying. Okay, well, what I did here was let's assume Q1 is telling the truth. Yeah, and this is like a proof by contradiction, isn't it? Yeah, because I'm assuming the opposite of what I'm trying to prove, and I'm going to try and derive a contradiction. Yeah, so I assume Q1 is telling the truth, i.e. a saint. Q1 equals S. Yeah, they should understand this kind of pretty obvious natural notation here, I hope. Okay, so if Q1 is a saint, then what do we know? Well, he's definitely telling the truth about the person to the left of him is lying, so Qn is lying, and Q2 must be a saint. Yeah? Now, okay, this seems all right at first, so far so good, but then what about Q2? Now, if Q2 is a saint, then Q1 must be a liar, and Q3 must be a saint. Yeah? This is impossible. This is inconsistent because we assumed Q1 equals S. So this is inconsistent. Yeah? Inconsistent. Sorry, I'm having trouble with my spelling today. Yeah, this is inconsistent. It's an example of, they call it in Latin, reductio ad absurdum, reducing the argument to absurdity. That's all proof by contradiction is. Like, you assume the opposite and you derive a contradiction. We've derived a contradiction here. Yeah, and so everyone Yeah, it's and like let's point out why this. You might argue, well, this just shows that Q1 must be, can't be telling the truth. But you could make exactly the same argument for Q2, exactly the same argument for Q3, etc., without loss of generality. Yeah, like that's the key thing. So this is inconsistent, and so Q1 must be a liar. The same argument can be made for every single person. Can be made for QI, yeah, like regardless, in other words, where people sit, yeah, because we could have just relabeled them. Hence, they must all be liars. You could actually as well investigate why everybody lying is consistent as well, and I like to do that. I like to show that what they claim is consistent. If everyone is lying, we have consistency as if Q1 is L, then okay, if he's lying about the person left lying and the person right being a saint, well, what is the opposite of this? How could this be? How could this be a lie? It could only be a lie if well, there's actually three ways this could be a lie, because you could have. Okay, right. Let's if everyone was lying, we have consistency. Let's just say. Let me write it down slightly differently. Q1 is L, Q2 is L, dot 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 all the way up to Qn is L. Now take any one of these. Let's take Q2. Yeah, when Q2 is lying and he's got two liars either side of him, that's still a lie. Yeah, because the person right, the claim is that the person on the right is a saint, but the person on the right isn't a saint, and hence the lie is intact. If you see what I mean, that is certainly still a lie because the person on the right is not a saint. Yeah. So I might just quickly write. We have consistency as that's the case, and for any Q, they are lying as the person on the right is not a saint. Yeah, that's where the lie is if you're worried about it. I don't think you need to put that, by the way, but I just like to. I like to show, yeah, it's consistent. It's all about consistent and inconsistent, these questions. That's all it is. And often it really helps to use the word assume. Yeah, whenever you want to consider possibilities, it really, really helps. Okay, with these questions, the last bit always tends to be the bit where it's like, how to explain myself here. Like, especially when they've told us the answer, because it's like a proof, isn't it? And they do tell you the answer here. They say, everybody makes a statement like, either person to the left and right are both lying, or right. So this is different from and. They always test the difference between and or. They really do. Make sure you understand it. So everybody's saying like left and right, either side are both liars, or, and I'm going to use Boolean algebra, either side are truth tellers, are saints. Yeah? That's what we're told. Everybody says this. Everyone says this. Okay, that's interesting. If at least one person is lying, show that n is a multiple of 3. So what I did was I said, okay, let's assume Q1 is the liar. Yeah, Q1 is a liar. Yeah, because we've got then at least one person lying. Yeah. Now what can we deduce? Then what can we deduce about Q2? Well, the person either side of him are both liars, or the person either side of him are both truth tellers. Well, lying about A or B, yeah, if you're lying about A or B, in other words, if A or B is false, then what is, the opposite of A or B being true? Well, neither A nor B being true, yeah? Then neither A nor B is true. Yeah, I'm going to write that down to justify my reasoning. Lying about A or B, then neither A nor B is true. Yeah, so if you're lying about either side both being liars or either side both being truth tellers, then both of these statements must be false. In other words, one side you've got a liar and the other side you've got a truth teller, a saint. Yeah, so okay, one person is telling the truth, the other is lying. Now let's let the liar. Yeah, let's assume Q1 is L, and then also now assume person to the right is lying. Yeah, because it doesn't really matter which side we consider here. So I'm going to say Q2 is L, yeah? Right, well, in that case, then Qn must be your saint, yeah? Because like we said, the opposite of A or B is neither A nor B. And so the opposite of either side both lying or either side both being saints is one of them being saint and one of them being a liar. We've assumed that the person to the right, Q2, is the liar, and therefore Qm must be the saint, yeah? Now repeat this process. Yeah, and what are we going to have? Well, consider Q2, who is also lying. So we need S and L either side of them. Now this time we're a bit stuck because we've already assumed that Q1 is L. So Q3 must be equal to the saint. Yeah, Q3 must be the saint because Q1 is already L. Yeah, so what have we got here so far for Q1, Q2, Q3 and Qm before? And we've got basically saint, liar, liar, and then we need this one as a saint. Yeah, and this pattern is going to repeat. We're going to need two L's and then an S and then two L's and then an S and then two L's. Yeah, now consider Q3, who is telling the truth. Yeah, they're a saint. Yeah, so this changes things. Yeah, and so both, when they're telling the truth about this statement, they must either both be liars or both be truth tellers. Now, as on to the left of Q3 we've got a liar, we must have to the right of Q3 a liar as well, and that way either side are both liars rather than either side both being saints. That's not possible because we've already got one liar to the left of them. And so if now consider Q3 is telling the truth, then Q4 must be an L. Yeah, Q4 must be an L here, so that either side we've got that. Now think about that pattern. That is just going to repeat. So the pattern repeats. And we're going to have, starting from Q1, L, L, S. Yeah, and then that saint turns the next person into a liar, and Q4 is going to be L, and then similar to this, it's going to be exactly the same reasoning. That's going to be L, and then Q6 is going to be S. Yeah. Now, I hope I've explained myself well enough, but I'm going to now point out that since Qn was assumed to be a saint, it had to be a saint for this argument to work. Well, let's just not assume there must be a saint under our original assumptions. Must be a saint under our original assumptions, and I'll visit these in one sec. I'll just write this down. Yeah, let's have a look. Q3, Qm was a saint. That's because we said Q1 was a liar. And if you're lying about that, then you need a saint on one side and a liar on the other. And remember, we assumed that Q2 was a liar. And so we've got it here, right here. Let's just highlight it. That means that Qn was the saint. Yeah, it had to be like that for Q2 to be the liar. And hence, since Qn must be a saint under our original assumptions, it follows that n must be a multiple of 3. Now, you might reasonably ask, well, what about, you assumed Q1 was a liar, yeah? What about if Q1 was telling the truth, yeah? So I could say OTOH. On the other hand, if Q1 is telling the truth, if Q1 is a saint, then we're exactly just here. We're at where Q3 is, basically. Because if they're a saint, either side are both liars or either side are both telling the truth, yeah? So if Q1 is a saint, yeah, you could try and have, okay, Q2. Q2 could be a liar. Yeah, we're going to have to do another assumption within this as well. We're going to say, okay, Q1 it could be a saint. So we'll have Q2. We'll assume Q2 is a liar. Yeah, in which case both sides have got to be a liar. Yeah, so then Qn is a liar. And the pattern we're going to generate this time is saint, liar, Qn, remember, must be a liar, Q3 must be a liar, and basically you're going to have the same pattern. Q4 is going to be a saint like that. And so, as you see, this time, this must be the liar, and basically we need that pattern LLS once again. It's the pattern which is going to be enforced, and so n must be a multiple of 3. For this pattern to hold. Okay, right. Let's have a little look about how it's explained in the mark scheme, because I do have it up here on my tab. It's always interesting to see this. Like, if only I don't understand the reasoning of not telling you how many marks a question is worth. They do the same on STEP, and I just don't know why they do it. Like, to me, it's a valid, valuable thing for a student to know exactly how much detail you need to go into by looking at the mark scheme. I think it's only fair. Okay, this was fine. We got 8 possible. We got 2 possible there. That was fine. And look, they don't go into that much detail. They're talking about consistency, though, which is definitely the words you want to use in these logic problems. And they've used the same notation as me with S's and L's, which is nice. Yeah, but they don't go into that much detail for those first 2, so I'm guessing that's fine. Now, here was the interesting one. Counting left to right, saints and neighbours. If not, then LLS. We had an LLS situation. The neighbour would have. Yeah, so they're assuming things here. It's very similar to the way I argue, but perhaps a little bit more concise. I'll be honest, and descriptive. As it only propagates LLL. Yeah, the only possible is LLL n times. I actually prefer the way I put it, actually, though, for that part A. But let's have a look at their part B. If one person is a saint, we are in a SSS. So they've assumed the first person is telling the truth, yeah? So SSS or LSL situation. I was just considering the LSL situation. If not, we are in an LLS or SLL situation. If we had an SSS situation, this could only consistently propagate as SSSSS, and no one would be lying, yeah? So yeah, that's the point. And I haven't said this. I think I'd definitely lose a mark here. So it's what mine's missing is at the end, you need to actually put yeah, because no, look, I haven't actually, look, this is poor. Yeah, if Q1 equals S and we assume both sides are telling the truth, it's like the trivial case. I.e. Qn equals S and Q2 equals S, then everyone must be telling the truth. We definitely are missing that. Must be telling the truth. And I can see why they started with that either, yeah? In which case, our original, because we're only interested in if at least one person is lying. So that is not possible under our, so we don't have at least one person lying. And that's why we can safely ignore that possibility, because you don't have at least one person lying. And that's why we need Q1 is S, Q2 is L, and that's when you're going to get SLL, 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 and you're going to get a multiple of 3. These are really hard to, describe your reasoning. They really are. That's the challenging bit. You can normally see why the answer is the answer, but using, simple notation like this is always a good idea. Anyway, what they said then, but LLS situation can propagate to LSL, then to an SLL, then to an LLS, etc., etc. So the situation down the table can be LLS, LLS, LLS. That is any number of repeats of LLS, or equivalently LSL or SLL. Really, they're just, looking at that bit here, yeah. Can I just, yeah, there we go, I've highlighted it. They're just looking at LSL there, or SLL. Well, they're just looking at, just starting from the S there. So it is the same thing. It is equivalent, yeah, provided, of course, that N is a multiple of 3. And it's because of that QN situation, which I assumed right at the start, QN crucially must be the same. And so by the time you come back round to them, they have to be the same. Okay, I hope you enjoyed that video. I hope it was useful. They are, logic problems are interesting, they're fun, they're kind of nice, but they're also kind of tricky as well, especially with explaining your reasoning. I hope you found it useful though, and all the best. Keep up the hard work.